Comparative analysis of precast and cast-in-place reinforced concrete frame of a multi-story building. Description of frame design solutions options. Eneca specialists have conducted a comparative analysis of a precast and cast-in-place reinforced concrete building frames. As a comparison, we have chosen one of the sections of a multi-story, multi-sectional reinforced concrete building. Both variants have the same cast-in-place foundation. While the frame of the building above the ground floor is designed in two versions, precast and cast-in-place. The cast-in-place frame is made of C2530 concrete and consists of walls 200 and 250 mm thick, floor and roof slabs 200 mm thick, as well as cast-in-place reinforced concrete beams. External walls are made of 3D bricks and insulation. The precast reinforced concrete frame is made of concrete C2025 and consists of interior walls made of single-layer panel 200 mm thick, external walls made of 3-layer panels 305 mm thick, as well as precast hollow core pre-stressed reinforced concrete slabs 220 mm thick, and cast-in-place parts for the floor slabs. Use of 4 and 5D beam for comparative analysis. Architects and structural engineers carried out the structural analysis, and the section of the building was modeled using 3D beam software. Tekla was used to model the precast frame, while Revit was used for the cast-in-place version of the frame. Then the 3D beam models were exported from Tekla to IFC format, and BX3 format was used for export from Revit. The models were imported in Bexel Manager for 4D and 5D beam. A corporate cost classification base has been imported from Excel to Bexel Manager. Each cost item of the classification contains the information about the necessary resources, their quantity and cost. Based on this information, Bexel calculates the cost of producing a unit of work. Bexel Manager enables you to link cost items to model elements, so that when a 3D model changes, the cost will be automatically recalculated and the schedule will be adjusted. For example, a new wall element has been added to the project. Selection sets with added and changed elements are generated automatically. At this stage, the cost of the new element is not included in the cost classification, and the time of its construction is not included in the schedule. After the automatic reassignment of the cost items, the added element is automatically linked to the necessary cost item, and we get the updated cost of the project, taking into account the added elements. After the schedule has been updated, the added item is automatically added to the necessary scheduled tasks, and the project duration is adjusted automatically. And vice versa, when changing cost items, the estimated cost will be automatically recalculated. The cost classification and its cost items are closely bound to the schedule. When the cost of any resource or resources has been changed, the software adjusts the project cost automatically. In addition, the cost is automatically updated in the tasks of the schedule. Bexel Manager has also given our team an opportunity to compare the two building frame versions, both effectively and visually. Power BI integration automatically generates detailed visual reports for your entire project. Power BI reports allow you to select certain building parts, for example stories and/or model elements, categories or families, necessary for the analysis, and display their cost characteristics, such as total cost, cost of materials, salary, the cost of operating machines and devices, and the cost of a unit of work. With its help, you can generate reports that can be viewed by any party concerned. The reports help you to visualize how different design options, materials, and resources affect the cost and duration of the construction. Pie charts are automatically generated as well. They show the costs associated with the concerned section of the cost classification, as well as the costs of materials, salary and operation of machines and mechanisms related to the selected section of the cost classification. In addition, a pie chart is also automatically generated for the selected parts of the building or selected elements, showing the distribution of above-mentioned expenditures. The used material resources, their quantity and cost, as well as the labor costs of workers and operators, and the used machines and mechanisms are shown for the selected section of the classification or selected elements. Results of precast and cast-in-place concrete frame analysis. The analysis resulted in the following data. Materials for the construction of the precast concrete frame account for 95%. Salary and machines and mechanisms account for 4% and 1% of the total funding, respectively. During the erection of the cast-in-place frame, materials account for 80%, and for salary and machines and mechanisms, 17% and 3%, respectively. To sum it up, we can conclude that a change in the hourly rate of workers or a change in the construction equipment leasing terms will not have a significant impact on the cost of the precast frame, while these factors will have a moderate impact on the cast-in-place frame construction. The main financial burden, both in precast and cast-in-place versions, is associated with the materials, concrete and reinforcement. A change in the market prices or delivery conditions for these two key material resources will result in a significant change in the cost of cast-in-place concrete frame, while a change in the pricing policy of a precast concrete production plant will lead to a significant change in the cost of precast concrete frame. Taking into account the outside finish, the cost of the cast-in-place concrete frame exceeds the cost of the precast concrete frame by almost 5%. From the labor intensity point of view, the construction of the cast-in-place frame, taking into account the outside finish, will take almost 5 times more man-hours. The construction duration of the cast-in-place frame building, taking into consideration the outside finish, will take up to 266 days in comparison to 56 days needed for the precast frame. Therefore, the construction of the cast-in-place concrete frame will cost more, and the construction period will be almost 5 times longer in comparison to the precast concrete frame. In conclusion, I would like to point out that 3D, 4D and 5D beam not only assisted our specialists in comparing the cost and duration of the multi-story building construction, both effectively and visually, but also enabled to give reasonable recommendations to all concerned parties.